Let's go ahead and look at adding and subtracting mixed numbers. All right, the first thing that we need to know is that a mixed number is actually a whole and a fractional piece. So if I were looking at 1 and 2/4, I am actually looking at 4/4 and 2/4. How do I know that 4/4 is the same as 1? Because I know that in order to have a whole of something, I need to have all of the possible pieces. In this instance, I'm going to say that it's over 4. My whole is going to be fourths because on my fractional piece, there is a denominator of 4. So 4/4 I have written here. I have 4 out of 4 pieces, and I also have 2 out of 4 pieces as well, according to the fractional piece of this mixed number. If I were to put them together, we can count them. It would be 1/4, 2/4, 3/4, 4/4, 5/4, 6/4 as an improper fraction, which really, if we went back and looked at this, that would be the same as taking this current mixed number and multiplying the number of pieces in a whole times the number of wholes we have, adding the 2 additional pieces in the fraction. So we have 4 times 1 is 4, and we're going to add 2 additional pieces, that's 6, and we are going to drag that same denominator under our mixed, from our mixed number to our improper fraction. All right, so now we know what a mixed number is. Let's go ahead and do some math with 1. So if we were looking at 1 and 1/3 plus 1 and 2, let's change that. Let's do 1 and 1/3 again. 1 and 1/3. We can actually go ahead and do what I like to call an invisible line. I usually start with the fractional side first, and this is the same. We can cover up the left side with the whole numbers so that the problem looks more manageable. So we are really only looking at the right-hand side over here. We are looking at 1/3 plus 1/3. Well, I know from my previous understanding of fractions that I cannot change the denominator here because they are the same. I'm trying to add the same size pieces to a particular whole or puzzle here. 1/3 plus 1/3. 1/3 plus 1/3 is going to be 2/3. If I were counting on a number line, that's exactly what I would find as well. If I were adding a 1/3 piece to a 1/3 piece, I would see that I had 2 of the 3 that I needed to make a whole. So then I can come over and I can look at my whole numbers and I can solve them separately. 1 plus 1 is going to be 2 wholes. My final answer here, because I cannot simplify, is 2 and 2/3. So because of that, I can look at the next one. Let's go ahead and do something like 4 and 3/4 minus 2 and 1/2. So this is pretty similar to what we've done before, only this time we are going to have a whole number portion as well. So we're looking at 3/4 minus 1/2. I'm looking only at my right side, which means I can solve it like that. 3/4 minus 1/2. I know that I cannot subtract these the way that they are because I have different denominators. So remember, step 1 is to find the same denominator. How do I do that? I look to see which one is larger and which one is smaller. Well, 4 is larger than 2, so I can ask myself, is 2 a factor of 4? Meaning, can I count by 2s until I get to 4? If I can, then that means I can quickly and easily find a common denominator of 4. So I'm going to rewrite 1/2 over here on the side as 1/2 equals something over 4. What am I multiplying by to get there? 2 times 2 I know equals 4, which means that I can multiply by 2 on the top. 1 times 2 is 2. I can rewrite my fraction now. So 3/4 stays the same. And I'm going to subtract 2/4 because that is my new fraction that is standing in the place of 1/2. 3/4 minus 2/4, I'm going to go back up to the top to solve it, equals 1/4. Now I can look over at my whole numbers. 4 minus 2. 4 minus 2 I know is 2. I cannot simplify this any further because 1/4 is already as low as it will go. Let's look at one more here. Sometimes we are going to end up with something like 3 1/3, and we are going to add, actually let's not make that 1/3, let's make that let's make that 2/5, and we are going to add 1 4/5 here. Okay, so this is the only time that addition is a little bit strange with mixed numbers. We're going to look to see if we have a common denominator. Check, we do. So we are going to solve that particular side. So we have 2/5 plus 4/5. They have the same denominator, so we are only adding together the numerators, 2 and 4. We have 2/5. If we run a number line and counted up 4/5 more, we would end up with 6/5. Looks a little bit strange, but let's go ahead and change that. I can pause right here because I know that I have an improper fraction. Because I have an improper fraction, I need to change it. So 6/5 is actually what? I can divide. I can say 6 divided by 5. I know that that's going to be 1, and I'm going to end up with a remainder of 1 over the possible 5. Another way that I can look at that is I can look at it as a number bond. I know that if I take away 5/5, I've taken away a whole. How do I know that? Because I need five pieces out of 5 over 5, to make a whole. Well, what is left of 6/5 if I take away 5/5? 1/5 is left. So either way that we do this, we know that 6/5 is the same as 1 1/5. So I'm actually going to go back to my original problem, and I'm going to add a 1 at the top, and I'm going to rewrite my 6/5 now as 1 1/5. Now I can go over and I can add the wholes. I have 1 plus 3 plus 1, which is 5. I cannot simplify any more than it already is, so I am done.